Hi, everybody, and for those of you who have been in Nashville for the past week, welcome back. I'm at UNI today at All-State Speech with Sam and Violet and Brooke, and to try and make sure that we have a productive day, what we're going to do today is go through a PowerPoint of the next section that we're going to be covering in geometry. This happens to be section 7.5, and the topic is proportions and parallels. This actually is the last section we're going to be doing in this chapter on similarity and proportions, although it will be after Easter when we get to our next test. Officially, what we do in this section is we learn a few theorems that deal with proportions and parallels, but really it's one of those things that just boils down to common sense. And what you want to do today is follow along with a few examples and make sure that you know how to do the types of problems we're going to be doing. The first rule that we're going to learn in this section officially has the name side splitter theorem. That comes from the fact that we're going to have a parallel line that splits up two sides. And it says if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides those sides proportionally. So that means that the fraction I could get by looking at the parts of the left side, that's going to be the same as the fraction I get by looking at the parts of the right side. So here's a real typical problem. The directions, if anything, would just say solve for x. And you can see we've got a parallel line to the bottom of the triangle. And it divides the left side into 12 and x plus 1. It divides the right side into 9 and x. And really, all we do is make a proportion where we get the fractions with what's on the left side and what's on the right side. So 12 over x plus 1 equals 9 over x. We're just going to cross multiply to figure out what x is. And here's the work of doing that. You can see we've got 12x equals 9 times the quantity x plus 1. I distribute out the right side. 12x equals 9x plus 9. Get all my x's on one side, so 3x equals 9. And when we divide, x has to equal 3. Again, I just set up the fractions from the left side and the right side, cross multiply, and I got the answer. So here's a very similar problem. You might want to take just a second, pause the video, and see if you can come up with the answer to this one. And again, all I do to solve this is I set up a proportion with what's on the left side of the triangle and what's on the right side of the triangle. A over a plus 4 equals 12/18. We cross multiply, we distribute, get all the a's on one side, divide, and finally our answer is a equals 8. Here's what your book calls the corollary to the side splitter theorem. It says if three parallel lines intersect two transversals, then the segments intersected on the transversals are proportional. So all this is really saying is you don't even actually need a triangle. You can have two lines that if you extended them would make those triangles, and as long as we have parallel lines, the parts of them on the left and the right have to be proportional. And so again, here's a real typical problem. I have these parallel lines. They intersect lines that on the left, you can see 4 and 6. On the right, 5 and x, and what we're supposed to do is figure out what x is. And all I do is set up a proportion with the parts of the left side and the parts of the right side 4 over 6 equals 5 over x. We cross multiply, and when we solve, we find that in this problem, x is 7.5. You can have similar problems that are expressed as story problems, but they're really no harder. This one says 3 campsites are shown in the diagram. What is the length of site A along the river? And you can see that along the river there's a blank and then 8 yards and 6.4 yards. And there's also measurements along a road at the bottom that say 9 yards, 7.2 yards, and blank. Well, what we want to do is find things that go together and that include what we're trying to get in this problem. Since we're trying to find out about campsite A along the river, it's basically the top left that would be our x in this picture. And I can look at the left part and the middle part and come up with x over 8 from the top and 9 over 7.2 from the bottom. Now, we could write this proportion a lot of different ways. Some people might write x over 9 equals 8 over 7.2. That's fine. You'll get the exact same answer either way, and you want to do whatever makes the most sense to you. But I put together things that go together and come up with my proportion. And once we got the fractions, what we've got to do is cross multiply. When we do that, we get a relatively easy answer. X is going to be 10 yards. So here's a follow-up question with the exact same picture. It says, what's the length of site C along the road? You might want to pause the video here and see if you can set up and answer that question. So here's a follow-up question. This time it says, what's the length of site C along the road? You might want to pause the video and see if you can answer that question. And you can see this time I used the middle and the right, and I came up with a proportion that said 8 over 6.4 equals 7.2 over x. I cross multiplied and I got 5.76 yards. Now again, you can write those proportions a bunch of different ways. You could, for instance, say 8 over 7.2 equals 6.4 over x. You'll get the exact same answer, and it's right either way. The final rule that comes up in this section, your book calls the triangle angle bisector theorem. And it says if a ray bisects an angle of a triangle, it divides the opposite side into 2 segments that are proportional to the other 2 sides of the triangle. Now what this is saying is if I made a fraction out of the 2 parts of the bottom of this triangle, it's going to be the same as if I make a fraction out of the left and right sides. You can use the sides of the triangle or you can use the bottom, and if you do left over right, it's going to be the same as left over right the other way. And so here's a typical problem like that. You can see that there's an angle at the bottom of this triangle that's bisected. The sides of the triangle are 12 and x. And at the top, the angle bisector cuts those into segments that are 10 and 18. And all we're going to do is make a couple of fractions. One of them I get from the sides of the triangle. One of them I get from the 2 parts of the top side. And each time I go in the same order, like left over right, left over right. That's why we've got 10 over 18 from the top, 12 over x from the sides of the triangle. And all we do to get the answer is just cross multiply. 18 times 12 divided by 10, and it turns out that x must be 21.6. Here's one more similar problem. And again, you might want to pause the video and see if you can set up and solve this one. And you can see I made a proportion with y over 24 from the sides of the triangle, 9.6 over 16 from the bottom. I cross multiply, and our answer is 14.4. And again, hopefully most of that really is common sense. We're going to get you started on an assignment from this section, and you can see it is on page 474. You'll be working on 1 through 5, 9 through 21, 31, 32, and 38 through 40.